Before the universe began, there was nothing. No stars, no time, no space. Just a tiny point, so small and dense we can't truly imagine it. This point held all the energy and matter that would become everything. We call it the primordial singularity. Here, the laws of physics as we know them didn't exist. Even time had no meaning. And then something extraordinary happened. About 13.8 billion years ago, that tiny point began to expand. This was not an explosion in space, it was an expansion of space itself. In a fraction of a second, the universe grew exponentially. This period is called cosmic inflation. Space stretched faster than the speed of light, and in that moment, time itself began ticking. The Big Bang was the beginning of everything: time, space, energy, and eventually matter. In the first millionth of a second, the universe was unimaginably hot and dense. Energy turned into particles, quarks, electrons, neutrinos, and more, and the strong and weak nuclear forces began to separate. Quarks joined to form protons and neutrons. The universe was a swirling plasma of light and particles, constantly colliding, transforming, and cooling. This chaotic moment set the stage for everything that would come. About 3 minutes after the Big Bang, the universe cooled just enough for atomic nuclei to form. This period is called Big Bang nucleosynthesis. Hydrogen, helium, and trace amounts of lithium formed. These are the lightest and most abundant elements in the cosmos, but atoms couldn't form just yet. The universe was still too hot. Photons bounced around in a dense fog of plasma. Light was trapped. The universe glowed, but it was not yet visible. 380,000 years later, the universe cooled enough for electrons to join atomic nuclei. Finally, complete atoms formed. This moment was called recombination. With electrons in orbit, light could now travel freely. The universe became transparent. That first light is still out there today. It's called the cosmic microwave background, or CMB. We can still observe it like a photograph of the infant universe. Even though light was now free, there were no stars. The universe entered the cosmic dark ages. It was a time of silence and simplicity. Gas, mostly hydrogen, filled the vast emptiness, but gravity never rests. Over millions of years, small clumps of matter began to grow. Slowly, these clumps collapsed into the first stars. A few 100 million years after the Big Bang, the first stars ignited. They were massive, many times larger than our sun, and burned hot and bright. These stars created the first heavy elements through fusion. Their light reionized the hydrogen gas, bringing an end to the dark ages. Groups of stars gathered into galaxies. Galaxies began to form vast structures shaped by dark matter. Filaments and voids filled the universe. The cosmic web had begun to form. The first stars burned fast and died young. They exploded in massive supernovae, scattering their contents across space. In these violent deaths, new elements formed: carbon, oxygen, iron, and more. These elements would later become planets, oceans, and life. Every atom in your body was once inside of a dying star. This cosmic recycling is actually how the universe built complexity from simplicity. Around 4.6 billion years ago, a giant cloud of gas and dust collapsed. It formed our sun, and around it a disk of leftover material spun. From this disk, the planets took shape: Mercury, Venus, Earth, Mars, and beyond. Earth began as a molten rock, then cooled, forming oceans, continents, and the atmosphere. Comets and asteroids bombarded the surface, bringing water and organic molecules. The stage was set for life. On Earth, life began in the oceans. Simple cells evolved over billions of years into plants and animals. Some of those animals became humans, and humans began to ask, where did we come from? What's the universe? So what we did is we built telescopes and satellites, looked deep into space, and discovered our origin story. From a singularity to galaxies to us. The universe is still expanding, faster than ever before. Galaxies are moving away, and space itself is stretching. In the distant future, stars will fade, galaxies will disappear beyond our sight, and the universe may grow cold and quiet. And the universe may grow cold and quiet once more. This is known as the heat death, a time when all energy is used up. But for now, we live in a moment of light, energy, and wonder. And every time we look up, we see a piece of that great beginning.